So you make epsilon very small, still the sequence will enter, perhaps after some time, right? So there is some delay, but it will still enter, right? An alternate way of saying this is, so you look at, for example, xn minus x, right? This is the difference. It's a vector, right? You look at the norm of this, okay? Well, it doesn't matter which norm you pick because of equivalence of norm. So let's take a 2 norm. And if you look at this, this is a sequence of number, right? For each n, xn minus x norm is a number, right? So you have a sequence of numbers, and I know what do you mean by this sequence of numbers going down to 0, right? So that sequence of number converges to 0 means you take an interval around 0, that epsilon room, it should enter, right? Okay, is this clear? Now we say that, so you take any sequence xn converges to x, then you look at f of xn. See, f of xn is a number, right? It's a sequence of numbers. So this should converge to f of x, right? So this is what you mean by continuity of a function f at xn. Okay. Now this is continuity of f. Now the second notion that we need in optimization is the derivative, right? So so let's look at the derivative of let f. You take a simple r to r itself, then how do you define df or dx? This is defined as, you look at f of x plus h, you look at f of x and divide by h, and then you take limit s tending to 0, right? So that will be that is the definition of a derivative, right? This is a recap. I'm sure all of you know this. So if I want to extend this to Rn, so what should I do? So let's say let the function f Rn to R, then, so what should I do? Yeah, I really don't know. I cannot take x is a vector, add h is another vector, subtract f of x, and I cannot divide by h, right? So h is a vector. I don't know how to divide, right? What should I do? I will just perturb the ith component of the vector x. So what do you mean by that? Then I'll write it like this: x1, x2, this is xi, xn. Okay, I'm going to look at the ith component. What I'm going to do is I'm going to perturb the ith component by h, right? Just add a small, I'll just increase xi by h, right? And now I'll subtract this by xn, right? So essentially I'll take the ith component, I'll move slightly in the direction of ith component, see what is the function value, subtract f of xi, x1 through xn, divide by h. What is this? And I take the limit going to 0. So what is this? This is your partial derivative, right? So you take the derivative of the function with respect to the ith component, right? So this is what you have, right? So now I can do that for every direction I, x1, x2, x3, and so on, xn. I get n derivatives. I collect them and I call it as what? What is that called? What is that called? I'll do this, right? So I have f with respect to x1, f with respect to x2, and so on, f with respect to xn. What is this called? Huh? No idea? I mean, at least should have seen this, right? What is this called? Huh? There's a name for this, right? I'm sure you would have studied this in your multivariable calculus or whatever, right? What is this called? Okay, I'll give extra 1 marks if you in the final. Huh?
It's called the gradient.
Okay, so you need such an incentive to answer, is it? Okay, so remind me towards the end.